Welcome to machine learning, and instantly notice how this is way too much. This is the three types of machine learning that you are used to know: supervised, unsupervised reinforcement. And this is everything that happened since you started learning machine learning. So this is a lot. There are a lot of types of machine learning. And in this mind map, the new mind map, I would like to explain to you all of these new types, because we are now in an era where you cannot just learn about supervised, unsupervised, and reinforcement. You need to know about all the other types of machine learning. And so this is what we're going to look at in this mind map. So I classified three different types of ways. We have type of supervision, the task, and the moment of learning. So let's begin with the type of supervision. You already know about supervised, unsupervised, and reinforcement. And you know, for example, that reinforcement is about learning from examples. And we have an agent behaving in an environment, and then we have action, reward. You may know about this. Now, I'm not going to dive too much into that. So I want us to look more about supervised and unsupervised. And when we look at this, we have strongly supervised, we have transfer learning, and we have weakly supervised. Okay, so these are the types of supervised learning. And then we have the types of unsupervised learning, which are fully unsupervised and self-supervised. Okay, so that's some information. Let us remove that and just focus on supervised learning and strongly supervised, which is what you already know. You have labels, you have data, and you're training a model. Now you also know about transfer learning, right? It's easy. You have a data set, and then you're training on another data set and using the learning from the first data set to make the training faster. So there is only one unknown, and it is weakly supervised learning. Okay, so what is weakly supervised learning? This is when we have very few labels, or when we just have half of the data set that is labeled, the other half that is unlabeled. And so we want to use some of these labels, and we want to use some other data sets. So we have three types of weakly supervised learning: when the data set is incomplete, when it's inaccurate, and when it's inexact. So when it's incomplete, you're usually using active or semi-supervised learning. So active learning is going to be this idea that we have an unlabeled data set, and we are basically going to predict the high confidence and the low confidence scores, and assign the low confidence scores to a human labeler that's going to then put the labeled data in the model, and then we're going to repredict over and over again. And this way we're going to always have the low confidence scores assigned to a human. And the rest is labeled automatically by a machine. And in semi-supervised learning, we're doing something a bit different, because we are going to use the labeled images, the distributions of the labeled images, as pseudo labels for the unlabeled images. So this is going to be a bit different, and in fact the image is a bit inaccurate because that's the top image that you're using as a pseudo label. Okay, so that is when it's incomplete, meaning that you don't have all the data, and so you're using the two. Then it can be inaccurate, meaning that you're going to have some noise and you're using multiple instance learning. And in this way, you're going to learn from bags of samples rather than individual labels. So for example, these are bags, and you're going to classify all the bags at once. And so basically you're going to have some noise, some errors, but in general that's going to get much faster, and then you can train models on that. And finally, you have data editing, which is when you have inexact labels, you have wrong labels, and you want to find these labels and then reverse them. So you could potentially use the two together. So that is weakly supervised learning. You have weak labels, or you don't have labels. So if you have weak labels, you can have low confidences, and then you're going to use that. Okay, so next, unsupervised learning. We saw that there are two types: fully unsupervised, and that's basically classification. So that's basically clustering. Okay. But you also have outlier detection, all of this. And self-supervised. And self-supervised is something different. you're going to create your own label from a learn label dataset just to learn something from these labels, and then you're going to go to fine-tuning this model under label data. And so these are all the types of supervision. Cool, so strongly supervised, transfer learning, weakly supervised, that is made of active learning, semi-supervised learning, multiple instance learning, and data editing. And then you have fully unsupervised and self-supervised learning and reinforcement learning. Okay, then you have moments of learning. So this is basically when do you train your data. It can be offline, which is what most algorithms do. They collect the data and then they train the model. Or it can be online. And when we're doing it online, we never stop learning. So we have, for example, incremental learning, which is, training continuously, having a pipeline that collects the data and then trains the model as fast as possible. And then you have collaborative learning and federated learning, which is basically thousands and millions of phones uploading, for example, a model on the cloud, and then you have some aggregated version that's going to be downloaded to every phone. So every phone, trains the model on its local data. The data never leaves the model, and finally, the model gets uploaded to the phones. Okay, so there is one thing that remains, which is the task. So we have several tasks possible. Single task learning, which is what you probably already know how to do. So for example, classification, regression, depth estimation, encoder, decoders, all of that. That is just predicting one task. You're building a model that can do something, one thing. And then you have multitask learning, which is basically a model that can do more than one thing. For example, a segmentation and a depth estimation head. Okay, so it has several heads, and each head is responsible of predicting one thing. Okay, so these are the two types of single task and multitask learning. Then we have contrastive learning. Contrastive learning is about pushing features in the embedding space, which means that you're going to, for example, learn and teach a model that two spam emails are close together and two non-spam emails are not close together. And so you're going to do that so that you can then use some things such as end-shot learning. And for example, you have zero-shot or one-shot learning, where you're basically doing, face recognition, for example. That is one-shot learning. You're going to have just one image pass through a neural network once, and then it tells automatically if this is the same image as the one in memory or in database or not. Then you have zero-shot and few-shot or many-shot learning. So these are other types. Then you have adversarial learning. So that is the idea of using, adversarial networks to, for example, fool a model. And you could fool a machine learning model, or you could also prevent fooling attacks. And finally, meta learning, which is learning about learning. So for example, you're going to take lots of examples of models and data sets, and you're going to learn a concept. So for example, instead of learning hot dog versus not hot dog, you're going to learn binary classification of images. And so that's the concept that you're going to learn. All right, we have our mind map. We understand much better all of these worlds. So thank you for looking at this. I hope that it's much more clear to you. And I have courses on each of these individual, at least some of these individual types of learning. For example, I have an entire course on multitask learning called HydraNets. Highly recommended, you're going to learn basically how to build this algorithm. And it's in general, I recommend learning more about these types, maybe even coding these ones, so that you have a really big overview and you have a good understanding of what you're doing.